stop. Don't just watch. Look at your hand. Turn it over. Look at the skin, the lines, the shadows. It looks solid, doesn't it? It feels real. You have a memory of clicking on this video a few seconds ago. You have a memory of waking up this morning. You believe with absolute certainty that you are a biological human being living on a planet called Earth, 13.8 billion years after the Big Bang. But here is the problem. The odds of a complex biological organism like you evolving naturally are so low that the calculator just says, error. It is infinitely more likely that you are a random accident. A collection of atoms that spontaneously jammed together 1 second ago in the deep void, tricked into thinking it is alive. In this video, we are going to peel back the skin of reality. We're going to look at the 3 pillars of physics: thermodynamics, quantum mechanics, and dark energy, and watch how they conspire to erase you. We will walk through the timeline of the deep future, where the lights go out and only the phantoms remain. By the end of this journey, you will have to make a choice. Either you accept that physics is broken, or you accept that you are a ghost. Welcome to the paradox. To understand why physics might prove that you do not exist, and to understand why your memories might be nothing more than a fever dream of the void, we cannot start with quantum mechanics. We cannot start with the Big Bang. We have to start with a tragedy. We have to go back to the turn of the 20th century, to a world that looked very different from ours, and to a man who looked into the abyss long before the abyss was ready to look back. The story begins with a rope and a window in a small hotel room in Duino, Italy. It is September 5th, 1906. The man in the room is Ludwig Boltzmann. He is 62 years old. He is one of the most brilliant minds in the history of the human species, and he is preparing to make his final exit while his wife and daughter are swimming in the Adriatic Sea just outside. To understand why he did it, you have to understand the war he was fighting. Today, if you walk into a classroom and talk about atoms, nobody blinks. You accept that matter is made of tiny, bouncing particles. But in the late 1800s, the atom was not a fact. It was a dirty word. The scientific establishment of Europe was dominated by men like Ernst Mach and Wilhelm Ostwald, the energetics movement. They believed that physics should only describe what you can see, touch, and measure. They looked at Boltzmann and they laughed. Mach would famously stand up in lecture halls, interrupt Boltzmann's derivation of gas dynamics, and shout, "Have you ever seen one?" Meaning an atom. To them, the universe was smooth. It was continuous. It was a perfect machine of energy flows that obeyed strict, unbreakable laws. But Boltzmann saw something else. He looked at the smoke from his cigar, swirling and fading into the air, and he realized that a smooth universe couldn't explain it. He realized that if matter was continuous, time should be reversible. You should be able to unburn a match. You should be able to unshatter a glass. But you can't. The arrow of time only moves one way. Things break, they don't fix themselves. Heat flows from hot to cold, never the reverse. Boltzmann knew that the only way to explain this one-way street, the only way to explain the arrow of time itself, was to assume that matter was made of trillions of tiny chaotic particles, colliding like billiard balls. He argued that the world wasn't governed by strict laws of destiny, but by the cold laws of gambling. He introduced the terrifying concept of statistical mechanics. He said that a cup of coffee cools down not because it must, but because it is statistically probable. He argued that order is just a rare configuration of atoms, and disorder is the natural state of the deck. This was a heresy. It implied that the solid reality we live in is just a lucky run of the dice. For decades, he fought this battle alone. He traveled from Vienna to Leipzig, debating the most powerful men in science, trying to convince them that the floor beneath their feet was a chaotic swarm. But the rejection was relentless. The mockery was constant. He felt like a man shouting the truth in a room full of deaf people. His mental health began to fracture. He swung between manic highs of intellectual clarity and crushing, paralyzed depressions. He suffered from what we would now diagnose as severe bipolar disorder, exacerbated by the feeling that his life's work was a failure. In 1906, convinced that physics would never accept his vision of a chaotic, atomic universe, he went on vacation to Duino with his family. He tried to rest, but the silence of the sea didn't help. The probability equations didn't stop running in his head. And so, while his daughter played in the surf, he made a terrible choice and silenced the argument forever. The cruelest irony of the history of science is that he was right. Less than a year after his death, Jean Perrin proved the existence of atoms experimentally using Einstein's paper on Brownian motion. Boltzmann died on the verge of total victory, but he left us something more dangerous than the atom. On his tombstone in the Central Cemetery in Vienna, there is no religious scripture. There is only a short, brutal equation carved into the stone above his bust. S equals K log W. This equation is the reason we are here today. It looks simple, but it is the seed of the nightmare. S is entropy. K is a constant, but W is the number of microstates, the number of ways you can arrange the atoms in a system. This formula tells us that high entropy, chaos, is simply more likely than low entropy, order. It tells us that the universe destroys structures not out of malice, but out of sheer statistical inevitability. But if you follow this logic to its ultimate conclusion, as Boltzmann did in his darkest moments, you find a loophole. A loophole that suggests that if you wait long enough, the chaos must accidentally create order. And that loophole is where the monsters are hiding. Let us pause for a moment before this grave in Vienna. Boltzmann's bust looks stern, almost angry, as he gazes at the equation that led to his demise. S equals K log W. You need to burn this formula into your brain because it is the source code of your own mortality. It explains why you die. It explains why stars burn out. And most importantly for our nightmare today, it explains why reality itself might be a lie. The letter S stands for entropy. You have probably heard entropy described as disorder. Teachers tell you that a messy room has high entropy and a clean room has low entropy. But that is a lazy explanation. Messy is a human opinion. The universe doesn't care about your opinion. The universe cares about probability. And that is what the letter W represents. It stands for Wahrscheinlichkeit, the German word for probability, or more specifically, the number of microstates. Here is how it works. Imagine you have a puzzle box with 1,000 pieces. If you dump the pieces onto the floor, there is only one specific arrangement where they form a picture of the Eiffel Tower. That is a state of order. That is low entropy. The number of ways to be the Eiffel Tower is exactly 1. W equals 1. But how many ways are there for the pieces to be a scattered pile of junk? Trillions. You can move one piece to the left, and it's still junk. You can flip 10 pieces over, and it's still junk. The number of junk microstates is functionally infinite. Boltzmann realized that the universe is constantly shaking the box. Atoms are always moving, colliding, and reshuffling. And because there are trillions of ways to be a pile of junk, and only one way to be the Eiffel Tower, the box will eventually destroy the picture. The universe moves from order to chaos, not because there is a force pushing it, but simply because there are more ways to be chaotic. Now, apply this to you. You are a biological machine. You are an incredibly complex arrangement of carbon, hydrogen, and oxygen. You are the Eiffel Tower puzzle. For you to be alive, your heart has to pump, your neurons have to fire, and your blood has to stay at 37 degrees Celsius. There is a very narrow set of arrangements for your atoms that equals alive. But there are an infinite number of arrangements that equal dead. If I scatter your atoms across the solar system, you are high entropy. If I turn you into ash, you are high entropy. Boltzmann's equation tells us that your existence is a statistical absurdity. You are a winning lottery ticket in a casino that is rigged to make you lose. Every second you stay alive, you are fighting the crushing weight of W. You are paying a tax of energy to stay in the rare, low probability state. But the math says the house always wins eventually. The box keeps shaking, and sooner or later, the atoms will find one of the trillion configurations where you don't exist. This is the second law of thermodynamics. It is the only law in physics that gives us a sense of time. The move from puzzle solved to puzzle broken is what we call the future, but this logic contains a trap that Boltzmann saw, and one that is about to snap shut on us. If entropy just means probability, and if the atoms shuffle forever, then forever is a very long time. If you shake the puzzle box for 5 minutes, you get junk. But if you shake the puzzle box for an eternity, eventually, purely by accident, the pieces will land in the shape of the Eiffel Tower again. It might take a googolplex of years, but it is not impossible. It is inevitable. And this means that order isn't the beginning of the universe. Order is just a rare, random ghost that appears in the machine if you wait long enough. So Boltzmann had his equation. He had the statistical explanation for why coffee cools down and why people die. It felt like a victory, but almost immediately he ran into a wall that nearly broke physics. He tried to prove something called the H theorem. He wanted to use the laws of mechanics, the basic rules of how atoms hit each other, to prove that entropy must always increase. He wanted to prove that the arrow of time is a law of nature, not just a suggestion. But here is the problem. He was using Isaac Newton's laws to do it, and Newton's laws have a fatal flaw. They are time symmetric. Imagine you're watching a video of a game of billiards. You see the white ball hit the 8 ball, and they bounce off each other at specific angles. It makes perfect sense. Now, imagine you play that video in reverse. You see 2 balls rolling backwards, colliding, and the white ball shooting back towards the cue. Does it look like magic? No. It looks like a perfectly normal physical event. If you showed that video to a physicist, they couldn't tell you which version was forward and which was backward. The laws of motion work exactly the same way in both directions. If you swap time, t, for minus time, minus t, in the equation F equals m, a, the math doesn't break. The atoms don't care about the past or the future. They only care about velocity and position. This creates a paradox that should make you question reality. If the fundamental building blocks of the universe, the atoms that make up your brain and your coffee cup, don't know the difference between the past and the future, then why do you? Why do you remember the past but not the future? Why can you shatter a glass but never unshatter it? Boltzmann tried to fix this with his H theorem in 1872. He created a quantity called H, which is related to entropy, and tried to show mathematically that purely due to collisions, H will always go down, which means entropy goes up. He argued that while individual collisions are reversible, the collective behavior of a billion gas molecules is not. He thought he had nailed the arrow of time to the wall. He thought he had proven that the universe has a direction, but he was wrong. He hadn't proven it. He had just hidden the assumption in the math. His critics, specifically Joseph Loschmidt, jumped on this instantly. They pointed out that if you took every single atom in Boltzmann's high entropy gas and suddenly reversed its velocity, just turned it around like the billiard balls, the entire system would run backward. The gas would unmix, the heat would flow back into the hot coffee, the shattered glass would jump off the floor and reassemble in your hand. According to the rigid laws of mechanics, this time reversal is a valid physical solution. There is nothing in the laws of motion that prevents the dead from waking up and living their lives backward to birth. The only reason we don't see it happen is, well, why? Boltzmann's answer was probability. It's just unlikely. But unlikely is a very weak shield to hold up against the terror of eternity. This failure of the H theorem to fully banish the reverse universe opened the door to the recurrence nightmare. If the laws of physics allow the glass to unbreak, then in an infinite universe, the glass will unbreak. Boltzmann had opened a Pandora's box. He showed us that time as we feel it, this steady march from yesterday to tomorrow, is not a hard wall. It is a statistical illusion, and illusions can break. The attack on Boltzmann's sanity didn't come from a stranger. It came from his best friend. In 1876, Joseph Loschmidt, a brilliant chemist and a close colleague of Boltzmann at the University of Vienna, identified the fatal flaw in the logic of the H-theorem. This moment is known in physics as the Umkehreinwand, or the reversibility paradox. It is the moment where the comforting idea of a stable, predictable timeline falls apart. Loschmidt looked at Boltzmann's model of colliding atoms and asked a simple, devastating question. "Ludwig," he essentially said, "your equations allow for a time machine. Here is the logic. We know that entropy increases as time moves forward. You break the egg, the disorder grows. But Loschmidt pointed out that if you took a movie of the egg breaking and played it backward, the atoms in the video would still be obeying the laws of physics perfectly. In the backward video, the yolk leaps off the floor, slides into the shell, and seals itself. The entropy in the video is decreasing. It is going from chaos, splat, to order, an egg. And here is the kicker. Since the laws of physics work in both directions, mathematically, the backward egg is just as valid a solution as the forward egg. There is no rule in the manual of the universe that says entropy must increase. So why don't we see eggs unbreaking? Loschmidt argued that if we are currently in a high entropy state, a messy world, then logically looking into the past should look exactly like looking into the future. If you start with a pile of ash, physics says that 5 minutes into the future, it will be scattered dust, higher entropy. But physics also says that 5 minutes into the past, it should have been scattered dust, higher entropy. This is the double-ended entropy problem. If you rely only on the laws of atoms, the past and the future should look identical. Both should be high entropy chaos, but they don't look identical. The past looks organized. You remember having breakfast, you remember the egg being whole. The past has low entropy. This massive contradiction suggests that something is wrong with our fundamental assumption about reality. Loschmidt forced Boltzmann to admit that his H-theorem wasn't a proof. It was a bluff. He couldn't derive the arrow of time from the laws of mechanics. The fact that you perceive time flowing forward, the fact that you remember yesterday but not tomorrow, isn't a hard law of nature like gravity. It is a mystery. It implies that the universe started in a state of impossible, miraculous order, the Big Bang, and we are just sliding down the slope from that initial miracle. But if the arrow of time is just a slide, what happens if the slide is slippery? Loschmidt's paradox suggests that our entire perception of cause and effect might be an illusion caused by our position on the slope. If you were standing at the bottom of the hill, looking up, the laws of time would look very different. You might see the dead waking up, cornered by his friend, mocked by his enemies, and staring at the collapse of his life's work. Boltzmann changed the game. He realized he couldn't beat Loschmidt with rigid mechanical laws. So he switched weapons. He abandoned certainty and embraced probability. This pivot is the birth of the terrifying world we live in today. Boltzmann famously responded to Loschmidt with a challenge. You say the atoms could reverse? Fine. You go ahead and reverse them. His point was about the sheer scale of the numbers. Yes, it is theoretically possible for the shattered egg to reassemble. The atoms could all coincidentally bounce off the floor at the exact angle required to launch the yolk back into the shell. But do you know how likely that is? Let's look at the air in the room you're sitting in right now. There are trillions of nitrogen and oxygen molecules bouncing around at 1,000 miles per hour. Right now, they are spread out roughly evenly. That is why you can breathe. But it is technically possible for all of them to bounce in the same direction at the same time. It is possible for every single molecule of air to spontaneously decide to rush into the corner of the room, leaving you in a vacuum unable to breathe. Physics does not forbid this. Newton's laws allow it. So why aren't you suffocating? Because the number of ways for the air to be spread out, high entropy, is a number with billions of zeros. The number of ways for the air to be in the corner, low entropy, is 1. Boltzmann argued that we don't see eggs unbreak, not because it is impossible, but because we don't live long enough to see it happen. He introduced the idea that the universe is just shuffling a deck of cards. An orderly state, like a living human or a whole egg, is like drawing a royal flush. It happens. But if you keep shuffling, you're going to draw a lot of garbage hands, chaos, before you see another royal flush. This defense saved his theory, but it came with a horrific price tag. By admitting that order is just a rare fluctuation, Boltzmann accidentally proved that order is inevitable if you wait long enough. Think about the air in the room again. If you wait 5 minutes, the air stays spread out. If you wait a year, it stays spread out. But if you wait an infinite amount of time, if you are immortal and you sit in that chair for eternity, eventually, the laws of probability say the air will rush into the corner. Eventually, the deck will deal the royal flush again. Boltzmann's defense turned the universe into a waiting game. He suggested that maybe our entire visible universe, the stars, the galaxies, the Big Bang itself, is just a rare, random fluctuation in a much larger, eternal dead space. He suggested that we are just a moment of accidental order in an ocean of eternal chaos. And just like the air will eventually rush back to fill the room, our universe will eventually dissolve back into the noise. But if we are just a fluctuation, a random accident of probability, then we have a new problem. A problem much worse than suffocation. Because if the universe throws random shapes together for eternity, eventually it won't just throw together a cloud of gas. It will throw together something that can think. Boltzmann used probability as a shield. He thought that by saying it takes forever, he could push the problem of the reverse universe so far away that it wouldn't matter. But in 1890, a French mathematician named Henri Poincaré stepped into the ring and turned Boltzmann's shield into a cage. Poincaré was a titan. He was the man who nearly beat Einstein to relativity. And while working on the famous three-body problem for a contest hosted by King Oscar II of Sweden, he proved a theorem that sounds more like a curse from a horror movie than a law of physics. It is called the Poincaré Recurrence Theorem. The logic is brutally simple. Imagine a box filled with gas. The box has a finite size. It contains a finite number of atoms, and those atoms have a finite amount of energy. Poincaré proved mathematically that because there is a limit to the number of possible positions and speeds the atoms can have, the system cannot generate new states forever. Eventually, it runs out of combinations. Think of it like a playlist on your phone. If you have 1,000 songs and you put it on shuffle, you can listen for a long time without hearing a repeat. You might hear a unique sequence for days, but if you listen for 1,000,000 years, eventually the algorithm has to play the same song again. Eventually it has to play the exact same sequence of songs again. Poincaré proved that our universe is just a very, very large playlist. It is a finite system of particles trapped in a box of space-time. This means that given enough time, the atoms in the universe are mathematically guaranteed to return to the exact starting position they are in right now. This destroys the concept of the end. We usually think of the heat death, the end of the universe, as a final state. The screen goes black and the credits roll. But the recurrence theorem says there are no credits. There is only a reset button. After the universe dies, after the stars burn out and the black holes evaporate, the particles will keep shuffling in the dark, and eventually, purely by chance, they will bump into each other in the exact configuration required to ignite a new Big Bang. This is the eternal return that the philosopher Friedrich Nietzsche had nightmares about. It means that this moment, you sitting there, reading these words, the light hitting your eyes, has happened before. Infinite times. And it will happen again. Infinite times. You are trapped in a loop of cosmic scale. Every mistake you ever made, Every pain you ever felt is etched into the geometry of the cycle. You cannot escape it because the atoms have nowhere else to go. But for Boltzmann, this theorem was the final nail in the coffin. It confirmed that the low entropy state, the order we see around us, is not a one-time gift from God. It is a recurring accident. We are just a temporary pattern in a kaleidoscope that is being turned by an idiot giant for eternity. And if the kaleidoscope turns forever, it won't just make pretty patterns. It will eventually make a pattern that looks back at itself and screams. So we have established the mechanism. The atoms shuffle forever. The loop repeats. But this brings us to the specific question of where we are in the loop right now. If the universe spends most of its time dead, a state of high entropy, cold equilibrium, and chaos, why are we living in the brief, shining moment of life? To understand this, we need to talk about fluctuations. Imagine a vast, calm ocean. The water's flat and boring. This is equilibrium. This is the state of maximum entropy. It is the state where nothing happens. But if you watch the surface closely, you will see tiny ripples, random movements of the water molecules. These are fluctuations. Occasionally, a few waves combine to form a slightly larger swell. Very rarely, a lot of waves combine to form a massive rogue wave that rises up out of nowhere, towers over the surface, and then crashes back down into the flat water. Boltzmann suggested that our entire observable universe, the billions of galaxies, the stars, the Earth, and you, is just one of those rogue waves. He proposed that the natural state of reality is a vacuum, a dead, empty void filled with drifting gas. But because of Poincaré's recurrence, that gas doesn't stay still. It fluctuates. Usually it forms small, useless clumps of dust. But once in a trillion years, a fluctuation is big enough to form a single star. And once in an eternity, a fluctuation is big enough to form a Big Bang. This is the Boltzmann universe hypothesis. It says that we are currently living inside a massive, accidental dip in entropy. We are riding the crest of a rogue wave that rose out of the chaos for no reason, and is currently crashing back down into the equilibrium. That explains why time feels like it's moving. We are on the slide. We are moving from the unlikely order of the wave back to the likely disorder of the ocean. But here is the trap. And it is a trap so subtle that it took physicists 50 years to notice it. If we are just a random fluctuation, then the laws of probability apply to us. Small waves are common. Big waves are rare. Massive waves are almost impossible. It is much easier for the ocean to make a small splash than a tsunami. Applying this to atoms, it is exponentially difficult to randomly assemble a whole universe with billions of galaxies. That requires a fluctuation of colossal, impossible size. It is much cheaper for the universe to assemble just one galaxy, and it is even cheaper to assemble just one solar system. So, if you are a random observer born from the chaos, statistics dictate that you should be in the smallest possible fluctuation compatible with your existence. You shouldn't see billions of galaxies. You shouldn't see a universe that is 93 billion light years wide. That is a waste of entropy. That is like winning the lottery a billion times in a row. You should be living in a tiny bubble of order, surrounded by chaos. You should be alone in a small room, with just enough air to breathe, and nothing else outside the walls. The fact that you see a giant universe is a massive statistical anomaly. It suggests that either we are incredibly, impossibly lucky, or that the thing seeing the universe isn't what we think it is. We have established that the universe is a casino. It shuffles matter randomly. And we have established that small accidents are much more likely than big accidents. Now, we have to talk about the price of your existence. And not in a philosophical sense. I mean the literal energy cost required to build you according to the standard story you believe. You believe you are the result of evolution. You believe in the long story. In this version, the universe started with a Big Bang. It expanded for billions of years. It had to fuse hydrogen into helium. It had to explode massive stars to create carbon and iron. It had to condense a solar nebula to form Earth. It had to wait 4 billion years for single-celled organisms to learn how to walk. And finally, after all that endless grinding work, it produced you sitting in that chair. Do you have any idea how expensive that story is? In thermodynamics, every event has a cost. That cost is paid in entropy. To create the order of a single human being via evolution, the universe had to waste a colossal amount of energy. Think about the sun. The sun burns 600 million tons of hydrogen every second. It sprays that energy out into the void. Most of it hits nothing. It is wasted heat. Only a tiny fraction hits the Earth to grow the plants that fed your ancestors. From the perspective of physics, the long story is an economic disaster. It is like burning down an entire rainforest just to toast a single slice of bread. The entropy created by the burning stars is astronomically higher than the entropy reduction of your small human brain. The universe is practically bankrupting itself to keep this timeline running. But there is a cheaper way. Remember the fluctuations? Remember the air in the room rushing to the corner? The laws of probability say that the universe prefers the path of least resistance. It prefers the state that requires the least amount of luck. So, compare two scenarios. Scenario A. The universe maintains a low entropy state for 13.8 billion years, organizes trillions of galaxies, and orchestrates a delicate chain of evolution just to make your brain. Scenario B. The universe stays in a high entropy state, chaos, and purely by accident, a random fluctuation arranges a few kilograms of atoms into the shape of your brain for just 1 second. Scenario B is infinitely cheaper. It requires less order, it requires less time, it requires less luck. The mathematical probability of a spontaneous brain appearing out of the void is e to the power of negative delta s. The probability of an entire Big Bang universe appearing is e to the power of negative delta s of the universe. Since the entropy of the universe is billions of times larger than the entropy of a brain, the math is clear. Nature is lazy. Nature seeks the ground state. If nature wants to create the experience of you, it isn't going to build a 13 billion year backstory. It is going to print you directly out of the vacuum. It is going to take the shortcut. This leads to a nauseating realization. If you accept the laws of thermodynamics, you have to accept that the long story is statistically impossible compared to the short story. It is overwhelmingly more likely that the universe is just a small, cheap fluctuation that looks like a brain, rather than a massive, expensive machine that creates life. You are the slice of bread, but there is no rainforest. There is no toaster. There is just a random flash of heat in the dark that feels like toast. Your intuition is screaming right now. You are thinking, this is stupid. I know the long story is true because I see the evidence. I have a belly button which proves I was born. I have a scar on my knee from when I fell off my bike in 1998. I see dinosaur bones in museums. The past is written on the world. This is a comforting thought. But in 1921, the philosopher Bertrand Russell took that comfort and shattered it. In his book, The Analysis of Mind, Russell proposed a thought experiment that has become a nightmare for physicists. It is called the 5-minute hypothesis. He asked, is there any logical way to prove that the universe wasn't created exactly 5 minutes ago? Think about it. Imagine a god or a random fluctuation creates a universe right now in this instant. But this god doesn't create a blank slate. He creates a world that is ready-made. He creates trees with rings inside them that imply they are 100 years old. He creates rocks with isotopes that imply they have been decaying for millennia. He creates you, sitting in your chair with a stomach full of half-digested food that implies you ate breakfast. And most importantly, He creates your brain with a web of electrical patterns that you read as memories. You remember falling off your bike in 1998, but that memory isn't a time travel tunnel to 1998. It is a physical arrangement of neurons firing right now. If I arranged your neurons in the exact same way 5 minutes ago, you would have the exact same memory. You would swear on your life that you felt the pavement scrape your knee, but there was no bike, there was no pavement, there was no 1998. There was just the creation of the memory of 1998. Russell's point was that the past is not a physical place. You cannot go there. You cannot touch it. The only thing you have is the trace, the footprint in the sand. But a footprint doesn't prove a man walked there. It only proves the sand is shaped like a foot. The wind could have shaped it. A random fluctuation could have shaped it. In a Boltzmann universe, this isn't just a philosophy game. It is the most likely explanation for what you see. Remember the cheaper argument? It is expensive to create a real dinosaur and let it die and fossilize over 65 million years. It is incredibly cheap to just create a rock that looks like a bone. It is expensive to live a life of 30 years to get a scar. It is cheap to assemble a patch of skin that looks like a scar. If the universe is playing the odds, and entropy says it is, then your belly button is a lie. Your childhood photos are props. The history of the world didn't lead up to this moment. The history of the world was created with this moment. You are a character in a video game who just spawned in, preloaded with a backstory to explain why you are standing in the middle of the level holding an object. You feel the weight of years, but you have only existed for the blink of an eye. We have talked about the universe. Now we have to talk about the machine that is interpreting it. We have to talk about your brain. You cling to your memories because you believe they are a continuous thread. You feel like a time traveler who is constantly carrying the luggage of the past into the future. You think that your memory of your first kiss is a real connection to a moment that happened 10 years ago. But physics disagrees. Physics says you are not a time traveler. You are a hard drive. Information in our universe is physical. It is not a spirit. It is not a ghost. It is an arrangement of atoms. When you save a file on your computer, you are not sending it to a magical digital dimension. You are physically changing the magnetic orientation of a piece of metal on a disk. A 0 becomes a 1. That is it. Your brain works the same way. A memory is not a video file. It is a physical structure called an engram. It is a specific strengthening of connections between neurons, mediated by proteins and ions. It is frozen chemistry. Here is why this is terrifying. If I hand you a book, you can read the story. But does the book contain the time it was written? No. It only contains the ink on the page. The story exists entirely in the present moment as a pattern of pigment. You infer the past from the ink, but the ink itself is just stuff sitting on a shelf now. Your brain is the book. The memory of your childhood does not exist in the past. It exists right now as a chemical state of potassium and sodium ions inside your skull. The feeling of remembering is just your brain reading the ink that exists in the present. This means that the past is not required for memory to exist. Only the pattern is required. If I could freeze time and rearrange the atoms in your brain to match the pattern of a French general from 1812, you wouldn't just know his strategy, you would be him. You would remember the cold of the Russian winter. You would remember the smell of gunpowder. You would feel the love for a wife you never met. You would swear those memories were real because the chemical ink is there. In a Boltzmann universe, the vacuum doesn't need to recreate the Napoleonic Wars to create that experience. It just needs to recreate the brain state of the general. It just needs to accidentally shuffle the atoms into the pattern of the engram. So, look at your own life. You remember eating breakfast this morning, but since that memory is just a chemical pattern existing right now, how do you know you actually ate breakfast? Maybe the universe just assembled your brain in this exact state 1 second ago. Maybe the breakfast pattern is just a random splatter of ink that your consciousness is misreading as history. You trust the data because it feels internal. But in a material world, internal is just code for current atomic arrangement. And atoms can lie. If you can't trust your memory, surely you can trust your eyes? You're looking at a screen right now. You see colors. You hear my voice. This sensory input feels raw and undeniable. It feels like you are looking out a window at the real world. But you're not looking out a window. You are trapped in a basement. In the 19th century, the physicist Hermann von Helmholtz realized a disturbing truth about human perception. He called it unconscious inference. He pointed out that the brain is locked inside a skull made of bone. It is pitch black inside there. No light ever touches your brain. No sound waves ever touch your brain. The only thing your brain ever receives are spikes of electricity traveling down a nerve cable. Your brain is like a prisoner in a dark cell who receives notes slipped under the door written in a code he doesn't fully understand. One note says, spike 40 Hz. Another says, spike 10 Hz. The prisoner has to guess what is happening outside. He guesses, that must be a dog barking. But he never sees the dog. He constructs a hallucination of a dog based on the data. Helmholtz argued that what you call reality is just a best-guess simulation constructed by your neurons to explain the electrical noise. You don't see the world, you model it. This is why optical illusions work. Your brain is used to light coming from above, the sun. So if I show you a drawing with shadows on the top, your brain hacks the image and tells you it is a hole, not a bump. It rewrites reality to fit its expectations. Now combine this with the Boltzmann paradox. If your brain is just a machine that turns electrical noise into a coherent story, what happens if the noise is random? Imagine a Boltzmann brain forming in the void. It has no eyes. It has no ears. It is just a lump of processing matter floating in a vacuum. But the thermal fluctuations of the universe are hitting it. Random radiation is zapping its neurons. The prisoner in the dark cell is getting notes slipped under the door, but the notes are just random gibberish from the chaos outside. Does the brain see chaos? No. The brain is an order machine. It takes that random noise and forces it into a narrative. It interprets the radiation as sunlight. It interprets the vacuum fluctuations as the sound of traffic. It hallucinates a body, a room, and a screen. You think you're seeing this video because light is hitting your retinas. But the exact same electrical signal could be generated by a random quantum fluctuation hitting your optic nerve in the deep void. Your conscious experience would be identical. You would sit there convinced you are watching a video about physics, while in reality, you are a fragile organ dissolving in deep space. The simulation is running on empty, but you can't see the edges of the screen. So far, we have argued that your brain is isolated in the dark, guessing at reality. But you might argue that even if your senses are flawed, your identity is solid. You know who you are. You know you grew up in a specific house. You know you loved your mother. You know you were lost in a shopping mall when you were 6 years old. Wait, did that last one feel familiar? In the 1990s, a psychologist named Elizabeth Loftus decided to break the human soul to see how it worked. She ran an experiment that destroyed the legal system's faith in eyewitness testimony and should destroy your faith in yourself. She recruited participants and contacted their families to get 3 real stories from their childhood. Then, she invented a 4th story, a fake one. She told the participants, "Remember when you were 6 and you got lost in the mall? You were crying, and an old woman in a flannel shirt helped you find your parents." At first, the participants said, "No, I don't remember that." But Loftus told them to go home and think about it, to visualize it, to try and find the memory in the noise. When they came back a week later, something terrifying happened. 25% of the participants didn't just admit the memory might be true, they remembered it. They started adding details that Loftus hadn't invented. One man described the specific bald spot on the old woman's head. Another remembered the toy he was holding. They wept real tears over a trauma that physically never happened. When Loftus revealed the truth, that it was a lie planted by researchers, many of them refused to believe her. They said the memory was too real. They trusted the hallucination inside their head more than the objective reality outside it. This proves that the human brain is not a recorder. It is a creative writing engine. It abhors a vacuum. If there is a gap in the data, it fills it with a story. Now, zoom out to the cosmic scale. If a human psychologist can overwrite your reality in a week just by asking you to think about it, what can the infinite random shuffling of the universe do? We established that the Boltzmann brain is a random fluctuation. It is a brain formed by accident. You might ask, how could an accidental brain know English? How could it know what a shopping mall is? The Loftus experiment answers that. It doesn't need to know. It just needs a seed. If the random fluctuation creates a tiny spark of pattern, a vague sense of loss or mother, the consciousness engine will instantly spin a backstory to explain it. It will invent a childhood, a language, and a planet to justify the feeling. You think your past defines you. But the science suggests that you are defining your past, constantly, in real time, to justify your existence in the present. You are not remembering 1998. You are writing it. We have reached the bottom of the rabbit hole for memory, and this is where we have to confront the ultimate horror of the Boltzmann Brain Paradox. It isn't just that your past might be fake. It isn't just that your perception is a simulation. It is that you might not endure. We have a deep, intuitive belief in continuity. You believe that the you who started reading this sentence is the same you who is finishing it. You feel like a river flowing through time. But physics suggests you are not a river. You are a frame. Think about a movie. When you watch a film, you see a character walk across a room. It looks smooth. But if you look at the film strip, nothing is moving. There are just 24 static pictures per second. The character in frame 1 does not move into frame 2. Frame 1 is destroyed. Frame 2 is a new picture that just happens to look similar. The movement is an illusion created by the speed of the transition. In the Boltzmann scenario, the fluctuation that creates your brain doesn't need to last for 80 years. It doesn't even need to last for 5 minutes. It only needs to last for the cognitive moment, the minimum amount of time required to think a single coherent thought. Neuroscientists estimate this is roughly 100 to 150 milliseconds. That is the lifespan of a Boltzmann brain. The universe fluctuates. The atoms collide. For one brief microsecond, they form a configuration that encodes the thought. I am watching a video about physics. Then, the fluctuation collapses. The atoms disperse. The brain fades. But in the infinity of time, another fluctuation happens later. It encodes the thought. That was a scary point. And another one. I should check the comments. These brains are not connected. They are separate entities separated by eons of dead time. But each one feels like it has been there the whole time. The brain that exists for 0.1 seconds comes preloaded with the memory of the previous 10 minutes. It feels the continuity. It feels the flow. But it is a lie. This means that you are not a continuous being. You are a series of disconnected flashes in the dark. The you that remembered the Loftus experiment in the last paragraph? Dead. Gone. Dissolved. You are a new fluctuation that just inherited his memories. You are a solitary spark that will exist for a fraction of a second, convinced you have a life, convinced you have a future, and then, click. You are gone. This destroys the concept of survival. You are terrified of the heat death happening in billions of years. But if this model is right, the heat death happens to you every time you blink. You are constantly fading away and being replaced by a new hallucination that thinks it is you. You are not living a life. You are just the current frame in a movie that nobody is watching. But if we are just frames made of atoms, where do the frames come from? How does the empty universe conjure up the hardware to run this nightmare software? To understand that, we have to look at the nothingness itself. We have to look at the vacuum. We have questioned your memory. We have questioned your continuity. Now we have to look at the engine that drives the whole nightmare. We have to look at the nothingness itself. When you imagine the vacuum of space, you imagine a void. You imagine a black box where nothing exists. You assume that if you take a box, suck all the air out, shield it from radiation, and cool it to absolute zero, you have zero. Zero energy, zero matter, zero movement. But in 1927, a German physicist named Werner Heisenberg proved that zero is the one number nature does not allow. Heisenberg introduced the uncertainty principle. You have probably heard the pop science version, you can't measure speed and position at the same time, but that is just the surface. The deep version of the equation involves energy, E, and time, T. It looks like this. Delta E times delta T is greater than h bar over 2. This equation is a shackle on reality. It says that the uncertainty in energy multiplied by the uncertainty in time must always be greater than a tiny constant number. This sounds technical, but the implication is shattering. If a region of space had exactly zero energy, then delta E would be zero. If delta E is zero, then to keep the equation true, delta T, time, would have to be infinite. This means a state of perfect nothingness would have to be frozen for eternity. Nothing could ever change, nothing could ever happen. But things do happen. Clocks tick, particles move. Therefore, delta T cannot be zero. This means that empty space, pure vacuum, is strictly forbidden from being empty. It must contain energy. It must tremble. Think of a pendulum. If you stop a pendulum and hold it perfectly still at the bottom, you know its position, bottom, and its speed, zero. Heisenberg forbids this. On the quantum scale, the pendulum must jitter. It must vibrate. This is called zero-point energy. It means that the vacuum is not a stage where matter dances. The vacuum is a dancer itself. It is a field of vibrating potential that can never be turned off. Every cubic centimeter of empty space in the universe, including the space inside your skull between your neurons, is humming with a minimum amount of chaotic energy. For Boltzmann, this is the missing fuel. He thought fluctuations were rare accidents in a gas, but Heisenberg showed us that fluctuation is the fundamental state of existence. The universe isn't a calm ocean that occasionally makes a wave. The universe is a boiling pot that cannot stop bubbling. And if the pot is boiling, it is going to cook something. So the vacuum shakes. But shaking is just motion. How do you get from shaking to a physical brain? How do you get from energy to matter? To answer that, we need to look at the work of Julian Schwinger and the strange reality of virtual particles. In classical physics, you can't get something for nothing. You can't create an apple out of thin air. That violates the conservation of energy. But in quantum mechanics, Heisenberg's equation offers a loophole. It's like a cosmic bank loan. The equation delta E delta says that you can violate the conservation of energy as long as you do it quickly. You can borrow a massive amount of energy delta E out of nowhere, as long as you pay it back in a tiny fraction of a second delta T. The vacuum uses this loophole constantly. In every inch of empty space, pairs of particles, an electron and an anti-electron, are spontaneously popping into existence. They borrow energy from the vacuum, exist for a nanosecond, and then crash back into each other, annihilating and returning the energy to the bank. They are called virtual particles, but that name is a lie. They are not virtual. They are real. They have charge. They have mass. They interact with the world. We know this because we can see them pushing things. In 1947, Willis Lamb measured the energy levels of a hydrogen atom and found a tiny discrepancy. The electron in the atom wasn't orbiting smoothly. It was being jostled. It was bumping into the invisible ghosts popping in and out of the vacuum around it. This is called the Lamb shift. It was the first hard proof that empty space is actually a crowded mosh pit of short-lived matter. This turns the vacuum into a 3D printer that never sleeps. Right now, in front of your face, electrons are being born and dying billion of times a second. Usually they die instantly. They are bound fluctuations. But what happens if they don't die? Boltzmann's theory relies on the idea that sometimes the particles don't crash back together. Sometimes the fluctuation gets lucky. Maybe a photon hits the pair and knocks them apart before they can annihilate. Suddenly, you have a real electron and a real positron. You have created matter out of nothing. If the vacuum can print an electron and it can print a proton, then it can print an atom. And if it has an infinite amount of time to roll the dice, eventually it won't just print a fleeting pair of particles. It will print a protein. It will print a neuron. It will print a fully formed observer, complete with memories of a life they never lived, floating in the dark, watching the fireworks of the void. You are not made of star stuff, as Carl Sagan told you. That is the romantic version. The horror version is that you are made of vacuum stuff. You are just a virtual particle that hasn't paid its debt to the bank yet, and the bank is coming to collect. You might be thinking, okay, virtual particles are cute. They explain tiny shifts in atoms, but they are ghosts. They can't move real objects. They can't build a world. You are wrong. Nothing is actually one of the strongest forces in the universe. If you give it the right conditions, a vacuum can crush metal. In 1948, a Dutch physicist named Hendrik Casimir predicted a phenomenon that sounded like magic. He said, take 2 uncharged metal plates, polish them until they are perfectly flat, place them in a vacuum, extremely close together, micrometers apart. Don't touch them. Don't charge them. Just leave them there. Casimir predicted that the plates would push themselves together. They would be crushed by the empty space surrounding them. For 50 years, this was just a theory. It was too hard to measure. But in 1997, at the University of Washington, Steve Lamoureux finally built a machine sensitive enough to test it. He set up the plates, he created the vacuum, and the plates moved. The force was real. Here is why this happens. It goes back to the idea that the vacuum is full of waves, virtual particles. Imagine the sea. If you have a wide open ocean, you can have massive waves, big, rolling swells. But if you build a narrow canal between 2 walls, the big waves can't fit. You only get tiny ripples inside the canal. The space between the plates is the canal. It creates a Casimir cavity. Only small, short wavelength particles can pop into existence inside the gap. But outside the plates, in the open universe, particles of all sizes, big, massive waves of energy, are crashing against the metal. The result is a pressure difference. The infinite storm of the vacuum outside pushes harder than the tiny ripples inside. The plates are pushed together not by gravity, not by magnetism, but by the sheer weight of the empty space itself. This changes everything about how we view the void. It proves that the nothing isn't just a background grid. It is a physical substance with pressure and density. We are walking on the bottom of an ocean of invisible water that is pressing against us from every angle. For the Boltzmann Brain Paradox, this is crucial evidence. It proves that the vacuum has mechanical power. It can do work. It can move matter. If the empty space can physically push a metal plate, it can physically push an atom. And if it can push an atom, it can assemble a molecule. The vacuum isn't just a printer, it is also the press. It has the energy, the material, and the muscle to build whatever the laws of probability demand. We have seen the particles. We have felt the pressure. Now we have to look at the stage itself. We assume that space, the coordinates x, y, z, is smooth. We think of the universe like a wax floor where atoms slide around. But John Wheeler, the legendary physicist who coined the term black hole, told us to look closer. He told us that if you zoom in far enough, the flaw dissolves. Imagine you're in an airplane flying over the ocean. From 30,000 feet, the water looks like a flat blue sheet. It looks smooth. This is Einstein's general relativity. It sees space as a smooth fabric that curves gently around stars. Now, jump out of the plane. Fall down to the surface. What do you see? You see chaos. You see waves crashing, foam bubbling, droplets spraying into the air. The smoothness was an illusion of distance. Wheeler argued that space works exactly the same way. If you zoom into the Planck length, that is 10 to the power of a negative 35 meters, a scale so small that an atom looks like a galaxy compared to it, geometry breaks down. Up and down lose their meaning. Past and future get tangled. Wheeler called this quantum foam. At this scale, space is not empty. It is boiling. Wormholes are constantly ripping open and snapping shut. Tiny bubbles of space-time are inflating and collapsing. Topology, the shape of reality, is changing billion of times a second. It is a storm of geometry. This is the mechanism of the nightmare. In a smooth universe, it is hard to imagine how a brain just appears. It feels too clean. But in quantum foam, reality is constantly trying to build things. The foam is churning out structures. Most of the time, the bubbles collapse instantly. They are micro-universes that die in the womb. But probability says that eventually, the foam will form a stable configuration. It won't just make a bubble, it will make a structure. Think of the foam like a soup of letters boiling in a pot. Usually the letters just spell A, G, Z. But if the pot boils forever, eventually the bubbles will rise to the surface and spell Shakespeare. This removes the last barrier to the Boltzmann brain. We used to think, where does the brain sit? It sits in the foam. What is it made of? It is made of the churn. The universe isn't a quiet place where accidents happen. The universe is an accident machine that is running at maximum capacity on the Planck scale, constantly vomiting out geometries. We are just the rare geometry that stuck together long enough to ask, where did I come from? We have the energy, we have the particles, we have the churning foam of space. Now we have to confront the final objection your brain is screaming at you. Complexity. You look at your hand or your iPhone or the eye of a fly and you think, chaos can't build this. You admit that chaos might make a rock or a cloud, but a microchip? A neuron? That requires design. That requires intelligence. Or at the very least, it requires the slow, guiding hand of natural selection over billions of years. But this intuition is wrong. It fails because your human brain cannot comprehend forever. You know the old saying, if you give an infinite number of monkeys an infinite number of typewriters, eventually one of them will write Hamlet. You nod and say, sure, technically, but you don't really believe it. You can't visualize the mountain of garbage text. The HG that the monkeys would type before they got to be or not to be. But in the Boltzmann scenario, the universe is the monkey. The quantum foam is the typewriter, and the timescale is infinite. This changes the math from impossible to inevitable. Let's look at an iPhone. It is a specific arrangement of silicon, gold, glass, and plastic atoms. It is a very rare configuration, but it is not a magic configuration. It is just a finite number of atoms in a finite number of positions. If the quantum foam spits out random clumps of matter for eternity, it will mostly spit out dust. Sometimes it will spit out a rock. But if it never stops spitting, it is mathematically required to eventually spit out the specific arrangement of atoms that corresponds to a fully charged iPhone 15. And then, 1 trillion years later, it will spit out the hand holding it. It doesn't matter that the universe is dumb. Randomness looks exactly like intelligence if you run it enough times. Evolution is actually the slow way to build a brain. Evolution has rules. It has to follow lineage. A fish has to become a lizard before it can become a monkey. It is constrained. Random fluctuation is unconstrained. It can jump straight to the finish line. It doesn't need to evolve the eye, it just needs to assemble the atoms of the eye. So, when you look at the complexity of your own mind, your thoughts, your dreams, your anxiety, do not mistake complexity for proof of history. You are just Hamlet. And the monkey has been typing for a very, very long time. This brings us to the conclusion of our look at the void. We used to think that life required a Goldilocks zone. We thought you needed a warm sun, liquid water, and a rocky planet to cook up the chemicals of life. We call this the primordial soup theory. But quantum mechanics tells us that the entire universe is the soup. Every cubic inch of the cosmos, from the center of the sun to the deepest, coldest void between galaxies, is made of the same quantum fields. The electron field, the quark field, the gluon field. These fields are the fundamental ingredients. They are everywhere. They are never turned off. This means there is no safe place where life cannot form. You don't need a planet. A planet is just a place where atoms happen to be clumped together by gravity. But the vacuum can clump them together by chance. The vacuum is a fertile environment. It is a boiling, pressurized, energetic factory that has all the blueprints and all the materials needed to build a human. It is doing it right now. In the time it took you to read this sentence, the vacuum inside your room generated and destroyed trillions of virtual particles. It tried to build something, failed, and recycled the parts. Most of the time, the factory fails. It makes noise. But we are about to enter the part of the story where we look at the clock. Because a factory that fails 99.999% of the time is still a terrifying machine if you leave it running for eternity, we have established the mechanism. We know how the universe can create a fake you out of nothing. It uses the thermal fluctuations of the quantum fields. We have established the motive. Nature prefers the cheap fluctuation over the expensive evolution. Now, the only thing missing is the opportunity. Does the universe have enough time to pull off this trick? Is the eternity real? Or will the universe end before the monkeys can finish typing? To answer that, we have to look at the timeline. And I warn you, the timeline is much, much darker than you think. We have built the machine, quantum mechanics. We have checked the price, thermodynamics. Now, we have to look at the calendar. This is where the human brain usually fails. You are biologically programmed to think in linear time. A day is 24 hours. A year is 365 days. A human life is 80 years. Civilization is 5,000 years. To you, ancient Egypt feels like deep time. To you, the dinosaurs vanishing 65 million years ago feels like an eternity. But in 1997, two astrophysicists named Fred Adams and Gregory Laughlin published a paper that destroyed our concept of long. It was titled A Dying Universe: The Long-Term Fate and Evolution of Astrophysical Objects. They realized that if you map the history of the universe on a standard linear graph, the graph is useless. If 1 inch equals a billion years, the graph would stretch past the moon. So they switched to a logarithmic scale. In this system, every step on the ladder isn't +1, it is times 10. Step 1 is 10 to the power of 1 years. Step 2 is 10 to the power of 2 years. Step 3 is 10 to the power of 3 years. Adams and Laughlin divided the lifespan of the universe into 5 distinct eras based on this scale. They mapped the story from birth to total oblivion. And when you look at this map, you realize something terrifying about your own location. You assume you're living in the middle of history. You assume that the universe is mature. But on the logarithmic scale, we are toddlers. The universe is currently about 10 to the power of 10 years old. That is a 1 followed by 10 zeros. It sounds like a lot, but the timeline extends to 10 to the power of 100. To give you a sense of that scale, if the entire lifespan of the universe was a 24-hour day and the Big Bang happened at midnight, We are currently at a billionth of a second, seconds past midnight. We haven't even started. This map reveals that the normal universe you see, the universe of stars, planets, and light, is not the main event. It is a brief, violent explosion at the very beginning of the party. We are living inside the opening credits. The real movie, the long, dark, cold movie, hasn't even begun yet. And this distinction between the era of light and the era of dark is the key to proving that you are a statistical anomaly. Let's look at where we are right now. Adams and Laughlin called our current time the stelliferous era, the age of stars. It began roughly 100 million years after the Big Bang, when the first gravity wells ignite the first hydrogen fusion. It is defined by one thing: energy is free. You look up, and there are giant nuclear reactors floating in the sky, vomiting light and heat into the void. Because of this free energy, life is easy. You can evolve biology. You can have liquid water. You can have solar panels. You can have a civilization that acts like a parasite on the side of a star. It feels stable. It feels like this is how the universe is. But stars are just fuel tanks. And fuel tanks run dry. The stelliferous era is strictly limited by the amount of hydrogen in the cosmos. We can calculate the deadline. The massive stars burn out fast, in millions of years. The medium stars, like our sun, last for billions. The tiny red dwarfs, the misers of the galaxy, can sip their fuel for trillions. But eventually, the tank hits empty. The last gas cloud will collapse. The last red dwarf will burn its final atom of hydrogen and fade into a white dwarf. The math says this era will end around the year 10 to the power of 14, 100 trillion years from now. That sounds like a long time, but remember the log scale. In the context of the total lifespan of the universe, 10 to the power of 100 years, the age of stars is a camera flash. Imagine you are in a pitch-black cave that has existed for 1 billion years. Someone strikes a match. The match burns for 1 second and then goes out. That match is the entire history of stars. That match contains the Big Bang, the dinosaurs, you, me, and every civilization that will ever exist. Why is this scary? Because of probability. If you were a random soul waiting to be born into the universe, and you threw a dart at the timeline to pick your birthday, what are the odds that you would hit the match? What are the odds you would be born in the tiny, tiny fraction of time where stars are shining? The odds are effectively 0. 10 to the power of 14 divided by 10 to the power of 100 is a number so small I cannot write the zeros here. Statistically, you should not be here. You should not be seeing stars. You should be born in the dark, cold future, where the stars are long dead. The fact that you are living in the flash suggests that either you won the ultimate lottery, or your existence in this era is a necessary illusion. We are the mayflies of the cosmos, dancing in a single spark, convinced that the light will last forever. But the darkness is already gathering at the edges of the map. So the match goes out. The year is 10 to the power of 14. The last red dwarf has exhausted its hydrogen. It flickers, gasps, and shrinks into a small, dense ball of carbon and oxygen. The age of stars is officially over. Welcome to the degenerate era. This name isn't an insult. It is a technical term from physics referring to degenerate matter, matter that is crushed so hard that the electrons refuse to move. In this era, the universe is a graveyard. It is dark, it is cold, but it is not empty. Floating in the blackness are the cooling husks of the stars. There are white dwarfs, Earth-sized diamonds that hold the heat of their former lives. There are neutron stars, city-sized balls of nuclear density. There are black holes, the silent kings eating the scraps. And there are brown dwarfs, failed stars that never lit up. This is the era of zombie astronomy. Occasionally, 2 brown dwarfs will crash into each other. The impact will briefly ignite a fusion reaction. A zombie star will flare up in the dark, burn for a few million years, and then die again. It is a ghost haunting the cemetery, but mostly this era is defined by the waiting. The white dwarfs start white hot, but over trillions and trillions of years, they radiate their heat away into the vacuum. They turn yellow, then red, then infrared. Finally, they become black dwarfs. A black dwarf is a dead star that has reached the same temperature as empty space. It is invisible. It is a frozen crystal ball of matter, drifting in the absolute dark. We have never seen one. The universe is too young to have created one yet. But in the degenerate era, they are the most common object in existence. If you were an observer in this era, you wouldn't see a sky. You would see perfect blackness. You would drift for eons without seeing a single photon. You would think the universe was empty. But if you turned on a flashlight, the beam might hit a black dwarf. You would suddenly see a dark, frozen sphere looming in front of you. The corpse of a sun that died a quadrillion years ago. This era lasts for a long time. From 10 to the power of 14 to 10 to the power of 40 years. That is a span of time so huge that the age of stars fits into it like a single second fits into the age of the Earth. If you are a betting man, you shouldn't bet on being born in the age of stars. You should bet on being a ghost floating in the graveyard. But even the graveyard isn't safe, because physics has one more betrayal left in its pocket. You assume that matter is stable. You think that even if the stars die, the atoms will remain. You think that a block of iron is forever. If you leave a black dwarf alone, surely it will just float there for eternity. Wrong. The standard model of particle physics suspects that atoms are not permanent structures. They are temporary knots in the field. And eventually, the knot unravels. This is the hypothesis of proton decay. It comes from grand unified theories, GUTs. These equations suggest that the proton, the positive particle at the center of every atom in your body, the chair, and the planet, is essentially radioactive. It just has a very, very long half-life, roughly 10 to the power of 34 years. That number is the deadline for matter itself. When the clock hits 10 to the power of 34, the degenerate era begins to end. The protons inside the black dwarfs start to pop. One by one, they decay into a positron and a pion. The positron hits an electron and annihilates into a flash of gamma rays. Think about what this looks like. The frozen, invisible black dwarf doesn't just sit there. It begins to glow from the inside. It is rotting. It is evaporating. The solid matter is turning into light. This is the ultimate horror for a materialist. We accept death because we think our stuff remains. Dust to dust. But proton decay says there is no dust. The dust itself dies. If you were watching the Earth in this era, you would see the planet slowly become translucent. The mountains would soften and dissolve into radiation. The oceans, frozen to ice, would sublime into light. Your own body, if it were preserved, would unspool like a cheap sweater. By the year 10 to the power of 40, the dissolution is complete. There are no more atoms. There is no carbon, no oxygen, no iron. The periodic table has been deleted from the universe. The black dwarfs have turned into clouds of photons and leptons, spreading out into the void. This means that matter, the solid stuff you touch, is just a phase. It is a temporary state of the universe, like ice is a temporary state of water. We are living in the brief, frozen phase where energy is locked into atoms. But the universe wants to melt, and in the deep future, it melts everything. So, who survives the melt? Who is left when the atoms are gone? Only the monsters. Only the things that aren't made of atoms. The gravity wells. The protons have melted. The atoms are gone. The physical stage of the universe has been wiped clean. But the actors are not all dead. Welcome to the black hole era. From the year 10 to the power of 40 to the year 10 to the power of 100, The universe belongs to the gravity wells, the black holes. These are the survivors. While the stars were dying and the matter was dissolving, the black holes were feasting. They grew fat on the corpses of galaxies. Now, they are the only things left. Imagine a universe that is totally dark. No light, no planets, just a vast, expanding void dotted with supermassive singularities. They act like vacuum cleaners in an empty house, sweeping up the stray photons and leptons left over from the proton decay. In this era, time loses its human meaning entirely. A year is too short a word. We have to speak in eons that make the age of stars look like a nanosecond. The black holes drift in silence. Occasionally, gravity pulls two of them together. They spiral inward. They merge. The collision shakes the fabric of space-time with gravitational waves, ringing the universe like a bell. But there is nobody to hear it. There is no matter to vibrate. Just pure geometry crashing into pure geometry. This is the ultimate simplification of reality. The complex chemistry of life is gone. The nuclear physics of stars is gone. There is only gravity and space. It is a clean, cold, mathematical perfection. If you were a consciousness trying to survive in this era, you couldn't be biological. There is no carbon. You would have to be a structure made of pure gravity or trapped radiation orbiting a singularity. You would be a parasite on a monster. But even the monsters are not immortal. They look stable. They look eternal. But in 1974, a man in a wheelchair proved that they are bleeding. Stephen Hawking changed the destiny of the universe with a single realization. He applied quantum mechanics to the edge of a black hole, the event horizon. Remember the virtual particles? The pairs that pop out of the vacuum? Hawking asked, what happens if they pop into existence right on the edge of the cliff? Here is the answer. One particle falls into the hole. It is trapped. But its partner, the other half of the pair, is just outside the edge. It escapes. It flies away into the universe as a real particle. But energy cannot be created for free. The energy to make that escaping particle real has to come from somewhere. It comes from the black hole itself. The hole pays the bill. This means that black holes are not perfectly black. They glow. They radiate energy. This is called Hawking radiation. And because they are radiating energy, they are losing mass. They are evaporating. It is a slow death. A painfully slow death. A solar mass black hole takes 10 to the power of 67 years to evaporate. A supermassive black hole, the size of a galaxy center, takes 10 to the power of 100 years. This is a Google years. The number 1 followed by 100 zeros, but eventually the clock runs out. As the black hole gets smaller, it gets hotter. It radiates faster. In the final moments of its life, the monster screams. It releases all its remaining energy in a massive explosion, a flash of hard radiation that lights up the dark universe for one brief second. And then, nothing. When the last black hole explodes around the year 10 to the power of 100, the era of monsters ends. The gravity wells are gone. The geometry flattens out. The universe enters the final phase, the dark era. There is nothing left but a thin soup of photons and neutrinos drifting apart forever. The temperature drops to absolute zero. The entropy hits its maximum. The story is over. Or is it? Because this is where the trap snaps shut on you. You think the dark era is the end. You think nothing can happen in a dead universe, but you are forgetting the first rule we learned in Act 1, probability. The universe is now a box of gas, photons, that will last for infinity. The timeline doesn't stop at 10 to the power of 100. It goes to 10 to the power of 500, to 10 to the power of 1000, to infinity. And in an infinite amount of time, even a dead universe starts to twitch. We have walked the timeline. We saw the flash of the stars. We saw the rot of the protons. We saw the death of the black holes. And now we stand in the dark era, which lasts forever. This is where the math forces you to make a choice. Imagine the entire timeline of the universe as a dartboard. The age of biology, the time where evolution is possible, is a tiny, microscopic sliver on that board. It is thinner than a human hair. The rest of the board, miles and miles of it, is the dark era, the era of thermal equilibrium. Now, imagine you are a generic observer. You are a consciousness waiting to be born. You throw a dart at the timeline to decide when you exist. Where does the dart land? Statistically, it is impossible for the dart to hit the age of biology. The ratio of alive time to dead time is 0. If you exist, you should be in the dark. But, you argue, I can't exist in the dark. I need a body. I need a planet. Do you? Remember Act 3. We proved that the vacuum is a machine that prints matter. We proved that given infinite time, the quantum foam will randomly assemble a brain. So, in the age of biology, nature builds brains the hard way. Evolution. There are a finite number of humans who will ever live. Let's be generous and say 10 to the power of 30 humans. That is a big number. But in the dark era, nature builds brains the easy way. Fluctuation. And because the dark era lasts for infinity, the number of fluctuation brains is infinite. This is the Bayesian catastrophe. Number of real humans, finite. Number of Boltzmann brains, infinite. If you pick a random conscious mind from the history of the universe, there is a 99.999% chance that it is a Boltzmann brain floating in the void. So ask yourself, why do you think you are the exception? Why do you think you are one of the rare biological lottery winners? The scary answer is, you don't know. A Boltzmann brain thinks it is biological. It hallucinates sunlight. It hallucinates a computer screen. It implies that your entire experience of the 21st century is just a random dream flaring up in the mind of a ghost, drifting through the heat death. You are not early in the universe. You are late, you are alone, and the darkness is the only thing that is real. We have now entered Act 5, the invasion. Up until this point, you might have treated this as a fun philosophical game. You might be thinking, well, infinity is a theoretical concept. Maybe the universe just ends. Maybe the timeline stops before the Boltzmann brains can form. That was the hope of the early 20th century physicists. They hated the idea of the Boltzmann brain. They called it a reductio ad absurdum, an argument so silly it proves the premise is wrong. Sir Arthur Eddington, the man who proved Einstein right during the solar eclipse, spotted this danger back in 1931. He looked at the math of fluctuations and realized it made no sense for God, or nature, to build a whole universe. If the goal of the universe is to produce an observer, why waste all that space? Why build 2 trillion galaxies just to put one observer on Earth? It is like building an entire Boeing 747 factory just to manufacture a single screw. It is bad engineering. Eddington argued that the Boltzmann universe, a tiny fluctuation containing just one brain, was logically superior to the Big Bang universe. But since we clearly see a Big Bang universe, we see billions of galaxies, our understanding of physics must be missing something. He believed that we would find a law that forbids these fluctuations. He believed we would find a wall that stops the monkeys from typing. For 60 years, physicists slept soundly. They assumed that the expansion of the universe would slow down. They assumed gravity would pull everything back together in a big crunch before the Boltzmann brains could take over. They thought the universe would die young, stopping the anomaly before it could grow. But in 1998, 2 teams of astronomers looked at distant supernovae to measure how fast the universe was slowing down. They found that it wasn't slowing down, it was speeding up. This discovery didn't just win them a Nobel Prize, it broke the safety lock on reality. It proved that there is no big crunch, there is no end. The universe is not going to die young. It is going to expand faster and faster, forever. Eddington's nightmare wasn't a mistake. It was a prophecy. And with the discovery of dark energy, the invasion of the phantoms became physically inevitable. The year was 1998. Two teams of astronomers, led by Saul Perlmutter and Brian Schmidt, were staring at Type 1 as supernovae. These are exploding stars that act as standard candles, light bulbs of known brightness. By measuring how dim they are, you can tell how far away they are. By measuring their color, redshift, you can tell how fast they are moving away. The astronomers were trying to measure the deceleration of the universe. Everyone knew the universe was expanding from the Big Bang. But everyone also assumed that gravity, the attraction between all the galaxies, was acting like a brake. They expected to see the expansion slowing down. They wanted to know when the car would stop. But when they plotted the data, the points didn't line up. The distant supernovae were too dim. They were much further away than they should have been. The car wasn't slowing down, it was hitting the gas. It was a shock that shook the foundations of physics. It meant that gravity is not the only player on the field. There is something else. A mysterious, invisible force that pushes space apart. We call it dark energy. And it isn't just a small nudge. It creates a repulsive pressure that grows stronger as space gets bigger. This discovery killed the Big Crunch. It proved that the universe will never collapse back in on itself. It will expand forever. And because the expansion is accelerating, it will eventually exceed the speed of light. This is the mechanism of our isolation. Right now, you can see billions of galaxies, but the space between us and them is stretching. Eventually, the galaxies will be pushed away so fast that their light can never reach us. They will fade from the sky. One by one, the stars will blink out. Not because they died, but because the space between you and them became uncrossable. The universe is ripping itself apart. It is isolating every local cluster into a lonely island, and this isolation creates the perfect laboratory for the Boltzmann nightmare. We thought we were living in an open, infinite sea. Dark energy proves we are actually living in a series of locked rooms, moving away from each other at warp speed. So the universe expands forever. You might think this saves us. If the universe gets bigger and bigger, the density of matter drops to zero. Surely in a universe that is infinitely big and empty, the fluctuations stop? No. This is where the geometry traps you. Because the universe is accelerating, it transforms into a specific shape known in mathematics as de Sitter space. In this geometry, you are surrounded by a wall. It is called the cosmological event horizon. It works like an inverted black hole. With a black hole, the event horizon is a sphere in front of you. If you cross it, you can't get out. In de Sitter space, the event horizon is a sphere around you. If you are standing in the center, there is a maximum distance you can ever see or influence. Anything beyond that distance is moving away faster than light. It is causally disconnected from you. As dark energy dominates, this horizon shrinks. It locks you in. You are trapped in a bubble of finite size. Here is the paradox. The universe outside the bubble is infinite, but your universe, the only part of reality you can interact with, is finite. You are stuck in a box. And we know what happens to particles in a box. Remember Poincaré? Remember the recurrence theorem? He proved that in a finite system, history must repeat. He proved that the atoms must shuffle through every possible combination. If dark energy didn't exist, the universe would have expanded into a thin, infinite mist where particles never touch each other again. The nightmare would have ended. But dark energy forces the universe to stay constant. It keeps the vacuum energy density the same. It keeps the horizon the same size. It builds a permanent cage, a cage that will last for eternity. And inside that cage, the quantum fields are bouncing off the walls, churning, fluctuating, and trying to build things. You are not floating in an open void. You are in a solitary confinement cell that has been designed to maximize the probability of hallucinations. So you are trapped in the de Sitter bubble. You might think, fine, I am in a cage, but at least the cage is cold. At least the atoms will eventually freeze and stop moving. You are wrong. The cage is electric. In 1977, Stephen Hawking teamed up with Gary Gibbons to calculate the properties of this cosmological horizon. They realized something shocking. The horizon of the universe behaves exactly like the horizon of a black hole. Remember how a black hole radiates energy because it rips virtual particles apart? Gibbons and Hawking proved that the edge of our universe does the exact same thing. Here is the mechanism. You are standing in the center. At the edge of your vision, the horizon, space is expanding at the speed of light. A pair of virtual particles pops into existence right on that line. One particle is pushed toward you by the expansion. The other is pushed away, over the edge, into the unobservable void. Just like with the black hole, the particle that flies toward you becomes real. It carries energy. This means that the wall of the universe is not a black curtain. It is a glowing surface. It is radiating heat inward, toward you. This is called Gibbons-Hawking radiation. The universe is essentially a giant microwave oven. The emitter is the horizon, and you are the turkey in the center. Now, the temperature of this radiation is incredibly low. It is about 10 to the power of negative 29 Kelvin. It is 1 billion times colder than the deep space we see today, but it is not zero. And in the game of eternity, the difference between 0 and almost 0 is the difference between being dead and being buried alive. The universe isn't just a prison, it is an active system. The walls are constantly bombarding the interior with thermal photons. The vacuum is shaking the cage. This radiation provides the one thing the Boltzmann brain needs to exist: a constant, endless supply of energy. This brings us to the concept of the eternal thermostat. We used to believe in the heat death as a freezing end. We thought the temperature of the universe would drop, and drop until it hit absolute zero. At absolute zero, all motion stops. Entropy stops increasing. The movie pauses forever. But the Gibbons-Hawking radiation prevents this. Because the horizon is radiating heat, the universe can never cool down below that specific floor temperature 10 to the power of negative 29 Kelvin. It hits a plateau. It effectively puts the universe into a warm bath state. Think about a petri dish. If you freeze a petri dish, the bacteria die. Nothing happens. But if you keep the petri dish slightly warm, just above freezing, and you leave it there for 1 billion years, chemistry happens. Molecules bump into each other. Things grow. The accelerating universe is a permanent petri dish. This creates a stable, eternal environment where fluctuations are physically guaranteed to happen. If the universe froze to zero, the Boltzmann brains couldn't form. The atoms would stop moving. But because the dark energy keeps the thermostat set to on, the atoms keep jittering. They keep trying new combinations. This destroys the last hope of the sane physicist. You cannot wait for the universe to die. It won't die. It will just enter a zombie state of low energy fever. And now, we can finally run the calculation that terrified the cosmologists. We have an infinite amount of time. We have a finite box, de Sitter space. We have a constant temperature, Gibbons-Hawking radiation. When you plug these three variables into the equation of entropy, you get a number that shouldn't exist. You get the number of phantoms, and that number is big enough to drown reality. We have arrived at the equation that breaks cosmology. In 2004, physicists Andreas Albrecht and Lorenzo Sorbo decided to run the numbers. They asked, in a universe dominated by dark energy, can we afford to ignore the fluctuations? The math works like this. The probability of a Boltzmann brain appearing in your room right now is incredibly low. It is calculated as the exponential of the negative entropy change, P equals E to the power of negative delta S. Roughly, this is 1 chance in 10 to the power of 10 to the power of 50. That is a number so small that if you wrote the zeros on every atom in the universe, you would run out of atoms before you finished the number. In a normal, dying universe, you could ignore this. You would say, the universe will end long before this unlikely event happens. But we just proved that our universe doesn't end. It has entered the de sitter phase. It lasts forever. So, here is the new equation. Total brains equals the probability per year multiplied by the number of years. You have a very small number multiplied by infinity. And in mathematics, any non-zero number multiplied by infinity equals infinity. This means the vacuum isn't just likely to produce a brain. It is guaranteed to produce an infinite number of them. It will produce a brain that thinks it is you. Then, 1 trillion years later, it will produce another one that thinks it is you. Then, it will produce one that thinks it is Napoleon. Then, it will produce one that thinks it is a chicken. Then, it will produce you again. Albrecht and Sorbo realized that the eternal thermostat of de sitter space turns the universe into a factory that runs 24/7, forever. It never stops printing observers. It creates a thermal runaway of consciousness. This implies that the Big Bang method of creating life, the method that requires stars, evolution, and parents, is just a momentary glitch at the start of the factory shift. It is a limited edition run. The standard model, the mass market product of the universe, is the Boltzmann brain. Now we have to put you on the scale. We have to weigh the probability of your existence. On the left side of the scale, we have the biological humans. These are the people born on Earth via evolution. They only exist in the stelliferous era, the flash of the match. Their number is finite. Even if we colonize the galaxy, we will eventually die out when the stars die. Let's say there are 10 to the power of 30 of them. On the right side of the scale, we have the Boltzmann brains. These are the phantoms born from the vacuum in the de sitter phase. They exist in the dark era. Their number is infinite. Now, imagine you are a soul being dropped randomly into a body in this universe. What are the odds you land on the left side? Human. The odds are 10 to the power of 30 divided by infinity. The answer is 0. The odds you land on the right side? Phantom? The answer is 100%. This is the verdict. If you trust the laws of physics, if you trust thermodynamics, quantum mechanics, and dark energy, then you cannot trust your own reflection. The math says that for every one real person watching this video, there are an infinite number of fake people hallucinating it in the void. If you are observing the universe right now, it is overwhelmingly, statistically certain that you are one of the fakes. You are not reading this on a screen. You are reading this in the random firing of neurons in a brain that has just assembled itself out of cosmic dust. There is no screen. There is no room. There is no Earth. There is only the hum of the radiation and the darkness of the cage. You are a ghost haunting a machine that doesn't exist. This conclusion seems inescapable. The logic is watertight. We use the best physics we have. But if this conclusion is true, it creates a final, devastating paradox that destroys physics itself. We have spent the last hour building a prison out of logic. We use the laws of physics to prove, step by step, that you are a hallucination. The argument feels solid. The math feels unbreakable. You feel trapped. But look closer at the lock on the cell door. There is a crack in it. The entire argument rests on one assumption. Physics is true. You believe in the Boltzmann brain theory because you believe in the second law of thermodynamics. You believe in quantum mechanics. You believe in dark energy. You trust the data. But wait. If you are a Boltzmann brain, where did that data come from? If you are a random brain floating in the void, then you never went to school. You never read a textbook. You never looked through a telescope. Your memory of reading Einstein's equations is just a random splatter of neurons. Your memory of the cosmic microwave background is a lie. This creates a logical self-destruction loop. 1. You trust the standard model of physics. 2. The standard model predicts that you are a Boltzmann brain. 3. If you're a Boltzmann brain, your memories of the standard model are false. 4. Therefore, you have no reason to trust the standard model. The argument destroys its own foundation. It is a snake eating its own tail. If the theory is right, then the evidence for the theory is fake, which means the theory might be wrong. This is not a physical paradox. It is an epistemological paradox. It means we have reached a point where logic disconnects from reality. You cannot use science to prove that science is a hallucination, because if science is a hallucination, its proof is worthless. This realization stops the panic. It tells us that something is wrong, not with you, but with the theory. The fact that the standard model predicts Boltzmann brains doesn't mean you are one. It means the standard model has a bug. In 2017, the physicist Sean Carroll looked at this loop and gave it a name. He called it cognitive instability. In science, we usually say a theory is wrong if it disagrees with the experiment. If I say the sky is green and you look up and see blue, my theory is wrong. But the Boltzmann brain theory is worse than wrong. It is unstable. Carroll argued that you cannot build a worldview that pulls the carpet out from under your own feet. Imagine a man who says, "I do not exist." If he is speaking, he is alive. If he is alive, his statement is false. But if his statement is true, he cannot be speaking. The sentence has no meaning. It is noise. Carroll applies this to cosmology. He says that any model of the universe that predicts that observers are mostly random fluctuations is a bad model. It is scientifically self-defeating. If a model says 99% of observers are unreliable, then we cannot rely on the observations used to build the model. This gives us a weapon to fight the monsters. We don't have to disprove the Boltzmann brain with new math. We can reject it on principle. We can say, I reject this theory because if I accept it, I can't think anymore. This forces physicists to go back to the drawing board. It implies that our understanding of the vacuum or the entropy of the universe is missing a crucial piece. Maybe the vacuum doesn't fluctuate as much as we think. Maybe the universe does decay faster than the brains can form. But this solution comes with a heavy price. To save your reality, you have to admit that our current physics is broken. You have to admit that we are missing a law of nature. And until we find that law, you have to make a choice. A choice that has nothing to do with math and everything to do with faith. So, we have a choice. We can accept the math and vanish into the void, or we can reject the math and save reality. But if we reject the math, what do we replace it with? On what foundation do we build our lives if we can't trust probability? To answer this, the philosopher David Albert introduced a concept that sits at the very bedrock of science. He calls it the past hypothesis. To understand it, imagine you walk into a room and see a glass of water with a half-melted ice cube floating in it. You ask a physicist, where did this come from? The physicist runs the equations backward. He tells you, clearly, 10 minutes ago, this was a fully frozen ice cube. It has been melting in the warm air. This makes sense. This is the historical explanation. But then, the statistician walks in. He looks at the water and says, wait, the atoms in that glass are moving randomly. It is statistically possible for the water molecules to randomly clump together to form a half-melted ice cube. In fact, it is much more likely for them to form a half-melted cube than a fully frozen one. The statistician is right. A fully frozen cube is a state of extremely low entropy. It is incredibly rare. A half-melted cube is higher entropy. It is more common. Therefore, purely by probability, it is billions of times more likely that the ice cube just spontaneously formed out of the water a second ago. rather than melting down from a perfect square. This is the Boltzmann problem in a glass. The math says the past, the frozen cube, never happened. So why do we ignore the statistician? Because of the past hypothesis. This is not a law of physics. It is not something we can prove. It is an axiom. It is a rule we simply decide to enforce. We postulate that the universe began in a state of extremely low entropy, the Big Bang. We assume that the past was orderly. David Albert argues that without this assumption, all of science falls apart. We cannot prove the Big Bang happened. We have to assume it happened to make sense of the ice cube. We have to assume the book on the table was written by an author, not assembled by wind. This means that your reality is not built on hard facts. It is built on a hard choice. We are looking at the chaos of the universe and consciously deciding to interpret it as a story, even though the math screams that it is just noise. We are forcing the universe to make sense by sheer force of will. This realization changes your position in the universe. Up until now, you have felt like a victim. You felt like a tiny observer being crushed by the weight of entropy and probability. You felt fragile because the math said you were a ghost. But the past hypothesis flips the script. It reveals that being real is not the default state. Being a ghost is the default state. Being a ghost is easy. It requires no energy. It requires no history. It is the path of least resistance. Being real, being a biological entity with a genuine past and a genuine future, is the hardest thing imaginable. It requires you to defy the odds. It requires you to hold a low entropy state against the storm of the vacuum. Think of reality not as a solid floor, but as a tightrope. The Boltzmann brains are the ones falling into the net. They are the ones surrendering to the chaos. You, by simply existing and perceiving a coherent world, are walking the rope. This makes your existence an act of rebellion. Every time you trust a memory, you're fighting the probability curve. Every time you plan for tomorrow, you're betting against the heat death. You're not a passive glitch. You are an active anomaly. This creates a new kind of fragility. We usually think reality is sturdy, like rock. But physics suggests reality is fragile, like a flame. It has to be fed. It has to be maintained. If you stop believing in the causal link between yesterday and today, the link dissolves. The universe is trying to gaslight you. It is showing you miracles, order, life, stars, and telling you they are accidents. The struggle of the conscious mind is to look at the accident and say, no, this is a story. We choose to believe that we are not brains in vats. We choose to believe that the other people in the room are not projections. We cannot prove it, but we make the wager. We bet our sanity on the idea that we are real, and because we all make that bet together, we create a shared world out of the void. We hold hands and form a chain that keeps us from flying off into the solipsistic dark. We have admitted that our foundation is an assumption. We assume the past is real because the alternative is madness. But this sounds like religion, not science. Are we just praying to the God of order? To answer this, we need to bring in the high priest of scientific integrity, Richard Feynman. In 1974, Feynman gave a commencement address at Caltech that changed the philosophy of science. He talked about cargo cult science. He described Pacific Islanders who built fake airports out of wood and straw, hoping to attract airplanes full of supplies. They had the form right. They had the antennas made of bamboo, but the planes didn't land. Feynman said that bad science is like a cargo cult. It looks like investigation, but it lacks the most important element, integrity. He defined integrity as a kind of leaning over backward to prove that you might be wrong. He said you must report everything that disagrees with your theory, not just the stuff that supports it. You have to be your own worst enemy. This is exactly what the Boltzmann Brain Paradox forces us to do. Most people want to ignore it. They want to say, it's silly, let's move on. That is the cargo cult approach. That is building a bamboo airport and pretending the universe makes sense. Real science demands that we look at the paradox and say, the math implies I am a ghost. I cannot disprove it. This is a problem. By acknowledging the trap, we transform. If you are a Boltzmann brain, you don't care about integrity. You are a random fluctuation. You have no control. But by choosing to care about the truth, even if the truth is that you might be fake, you are demonstrating a quality that randomness cannot generate. Randomness creates patterns. It does not create standards. Feynman implies that the act of questioning your reality is the only thing that validates it. A hallucination doesn't check its sources. A hallucination doesn't try to prove itself wrong. The fact that you are willing to doubt your own existence is the strongest evidence that you are more than just a flash in the pan. You are engaging in a process, and processes require time. So, we have honesty. Now we need a strategy. We are standing at the poker table of the universe. The dealer, Entropy, has dealt us a hand. We don't know if the cards are real or if we are dreaming them. How do we bet? We have to use game theory, specifically a modified version of Pascal's wager. Blaise Pascal used it to argue for belief in God. We will use it to argue for belief in reality. Here is the payoff matrix. Option A. You fold. You decide that the math is right. You are a Boltzmann brain. Nothing is real. The future doesn't exist. If you are right, you win nothing. You dissolve into the void in 1 second. Your apathy didn't save you. If you are wrong, you waste a real life. You spend your precious, finite time in a state of nihilistic paralysis. You lose everything. Option B, you go all in. You decide to act as if you are real. You build relationships. You learn physics. You create art. If you are wrong and you are a phantom, it doesn't matter. You dissolve. You lost nothing because you never had anything. If you are right, you win the universe. You participate in the grand chain of cause and effect. You leave a mark on the timeline. When you look at the matrix, the logic is undeniable. There is no strategic advantage to solipsism, even if the probability of being real is 1/10,000,000%. The value of being real is infinite. The value of being a ghost is 0. Therefore, the only rational move is to play the game as if it is real. This isn't about faith, it is about math. The expected value calculation demands that you live. It demands that you treat your memories as facts. It demands that you treat the person next to you as a conscious observer, not a projection. By making this wager, you define yourself. A Boltzmann brain cannot make a wager because it has no agency. It just is. By choosing to bet on reality, you are simulating the behavior of a biological entity so perfectly that the distinction doesn't matter anymore. If you play the game hard enough, you become the player. We have made the wager, we have decided to play. But there is one final argument that suggests we are not just players, but the creators of the game board itself. We often ask, why is the universe so fine-tuned for life? Gravity is just right. The expansion rate is just right. If the nuclear force were 2% weaker, stars wouldn't burn. It feels like the universe knew we were coming. The skeptics say this is just the anthropic principle. They say, if the universe wasn't fine-tuned, we wouldn't be here to notice it. It is a selection bias, but John Wheeler, the man who showed us the quantum foam, took it a step further. He proposed the participatory universe. He argued that the universe does not exist out there, independent of us. He looked at quantum mechanics, specifically the double-slit experiment, and saw that particles don't have a definite location until they are measured. The act of observation forces the universe to decide where it is. Wheeler suggested that this applies to the whole cosmos. The Big Bang, the stars, the galaxies, they exist as a fuzzy probability cloud until an observer evolves to look at them. By looking back at the Big Bang, we are physically causing it to happen. We are the eye that the universe grew to see itself. This answers the Boltzmann paradox. A Boltzmann brain is a lonely observer. It has no history. It creates no past. But a biological observer, you, stands at the end of a long chain of evidence. You look at the fossil, the photon, the star. You weave them into a reality. Without you, the universe is just a dark equation. It has no size, it has no age, it has no color. You are the machine that turns the math into the world. You are the rendering engine. This means you are not an accident, you are a requirement. The universe needs you to exist. It needs you to collapse the wave function. It needs you to validate the timestamp. You are the anchor that keeps the timeline from dissolving into the dream of the void. So here is the final picture. The laws of thermodynamics want you to be dust. The laws of quantum mechanics want you to be a fluctuation. The laws of dark energy want you to be alone behind a horizon. The timeline of eternity wants you to be dead. Every single force in the cosmos is pushing against your existence as a coherent, biological being. The universe is a machine designed to grind structure down into nothingness. And yet, here you are. You are sitting in a chair, defying the entropy of the sun. You are holding a memory of yesterday, defying the erasure of time. You are imagining a future, defying the heat death. You are the glitch. You are the anomaly that the math couldn't predict. We started this journey by asking if physics proves you don't exist. And in a way, it does. It proves that you are impossible. But the fact that you exist anyway, the fact that you are experiencing this moment despite the infinite odds against it, makes you the most miraculous thing in the dark. You are the resistance. Simply by taking a breath, you are winning a war against the void that has lasted for 13.8 billion years. So, do not let the Boltzmann Brain Paradox drive you to despair. Let it drive you to awe. The darkness is vast, yes. The silence is eternal, yes. But for this brief, shining moment in the stelliferous era, the lights are on, the camera is rolling, and you are the only one watching the movie. The universe might be a casino rigged for the house, but somehow, against all logic, against all probability, you manage to sneak in and steal a jackpot of consciousness. Do not waste it. Do not fold. Play the hand you were dealt. Now, I want you to do it one last time. Pinch your arm. Feel that? That sharp sting? That is data. That is the raw, undeniable signal of reality entering your consciousness. No equation can delete that feeling. No paradox can argue with pain. That feeling is your anchor. It is your proof that you are here, right now, participating in the impossible game. We have looked into the abyss today. We have stared at the monsters of entropy and the ghosts of the vacuum. It is heavy. It is terrifying. But remember, the abyss only looks back because you are there to look at it. If this journey through the nightmare of physics shifted your perspective on reality, help the signal reach other observers. Click the like button. It tells the algorithm that we are real. Subscribe to Acronium and ring the bell. We have many more blueprints of the universe to deconstruct, and I need you here to collapse the wave function of the next video. And I want to know your verdict. Go to the comments and tell me. Are you a biological observer, fighting the good fight? Or are you a Boltzmann brain, and this video was just a hallucination? I read every comment to remind myself that I'm not alone in the dark. Keep looking up. Keep asking the dangerous questions. And remember to breathe. You made it to the end. You exist. With you was Acronium.